This is The Water Table.
A chance to hear the agricultural side of these issues.
A place for people to go find information and education.
Water management is just going to become even more critical into the future.
How misunderstood what we do is.
I would encourage people to open their minds and listen to this dialogue.
Welcome to the Water Table Podcast. Thank you for joining us today. Today we have Chuck Brandel from ISG in Mankato, Minnesota. We're going to let Chuck kind of introduce himself, but we're really excited to have ISG represented here today at Prinsco. We've worked closely with them on different projects. So we're just going to talk about water quality and agriculture with some of the projects that they've been working on. Welcome, Chuck.
Yes, thank you. Again, I'm Chuck Brandel. I'm an engineer in our Mankato office. ISG, we have offices in 4 states, Minnesota, South Dakota, Iowa, and Wisconsin. And I lead our water business unit. I've been working in the ag sector or the rural drainage sector for many years. So I've designed many projects specifically throughout Minnesota, but also throughout the upper Midwest.
Well, thank you. Thanks for joining us. Also, one of the ways that you've connected with Prinsco over the years, or one of the major ways, is through our engineering team. And also Jason Ahrenholz is joining us again today to kind of help guide the conversation and to talk through some of the questions that we have about engineering and water quality and agriculture.
Yeah, thank you for having me again. Just kind of want to start out by asking Chuck some questions. And obviously, you mentioned you've had many years of experience of design of agricultural drainage systems, and maybe you can expand a little bit on how has ISG's focus on water quality shifted how you're doing designs?
Well, it shifted quite a bit. I've been with ISG 20 years, and in the past 20 years, we've seen a lot more focus on water quality, both internally and externally. Internally, we used to call everything ag drainage for rural surface water. And now our team is a water resources team, because we have to look at both the drainage side of things and the water resources that we drain into. So we've had much growth in the past 20 years, and we've shifted focus that every project we do, we try to incorporate some sort of water quality into that, especially when we're looking at in Minnesota, the streams and lakes that we drain into, and are there ways that we can protect those at the same time improving the drainage for the producers on the landscape.
Yeah, that's interesting, Chuck, that you mentioned, how much your firm has changed and how much more emphasis there's been both externally and internally on water quality. And what do you see in regards to like climate change? Do you think that plays a role in that we're having a lot more large rain events in the upper Midwest that is partially why that focus has shifted?
I think that's a big part of the focus. We have more highly intense rain events. We've had a lot of flooding over the past 10 years. I believe the last 10 years are the wettest 10 years on record in Minnesota. So we've got the need to handle water more because we have more of it at higher rates at times. But we've also seen that on the producer side, farming has changed from when a lot of these systems were designed 100 years ago. We've got larger equipment. We've got larger farms. We've got higher input costs, and we need to be able to get in and out of fields when we can. At the same time, we've got to protect our downstream resources.
Absolutely. And I think that's what's really important for our listeners to hear too, is really that impact on our farmers and the ability for them to get in and out. You mentioned a little bit with water quality being a factor in all designs moving forward. How has regulation kind of pushed that, or is that bore out of a desire from our end users and our customers?
Well, when you look at Minnesota public drainage, the statute's 100 years old, and there are portions of the statute that say your outlet must be adequate, that you essentially cannot pass a problem downstream. I think in the especially last 10 years, there's been a more focus on really following that law. So that law is not a new law. We have been trying to implement new ideas into the ag drainage world that maybe are ahead of legislation. I feel that we've done some of the first large ponds on some of these drainage systems, looked at how we can incorporate wetlands into the drainage systems and other BMPs. And really that's to protect those outlets. We have streams and lakes that have been flooded, that have experienced high levels for a long time due to the large amount of rain that we have. At the same time, like I said previously, the farming practices, we need to figure out how to manage the water well. So we've been utilizing storage as one of the main BMPs or best management practices to try to accomplish the goals, and what I call a win-win scenario, where the producers can get more crops off of their fields, higher production rates, and at the same time we can maybe improve water quality downstream.
Yeah, one of the things that I just want to share, as some of our listeners are our city cousins and don't know as much about agriculture as some of our customers and people that make their living in agriculture. But when Chuck mentions around the ease of getting into the field and being able to get into a field with all the modern equipment and things, what we see in the water management side and with our products is when our products will help you get into the field earlier. There is a certain time around the 10th of May in which every day after that they don't have their fields planted, they see about a bushel per day yield loss per acre. So if you're talking about, 15 days late, 15 bushels an acre is a significant amount, and probably is that profitability part for the farmer where that year is profitable or isn't. So it is critical that they get into the field, and water management is a big piece of that if the field is dry enough or not to access.
Once the crop is in the field, if you get water sitting in areas for too long, you will kill the crop. But the one unique thing as an engineer designing drainage projects is we can have some storage in the fields, and we can use storage in the both on top of the landscape and in the soil. So if we can utilize those things and get the timing right, we can store some water, but at the same time, we can't store it too long, or we'll get the crops to die, and then we'll have lower yields at the end of the year.
Yeah, say a little bit more about that. I don't know that we were planning on going down that road, but it is an interesting road that I don't know if the dots are always connected around storage availability within the soil profile. So if you have pipe in the ground at, just say, an average of 4 feet, between that 4 feet and the surface, there is area to store some water. But from an engineering perspective, can you explain that more and talk a little bit about that?
Yeah, when you have drainage systems in place, you can lower the water table to where the drainage system is at. And so during a dry time, you've got a soil profile that could accept some water. And then if you manage that correctly, you could utilize that 4 or 5 feet of depth, depending on how deep your tile is, for storage within the soil. A lot of cases, there's ways to control that with controlled drainage. That's one of the best management practices that we suggest to landowners. On our larger projects, we typically don't get to design the controlled drainage because that's a field or landowner-based decision, not the main or the main county outlet decision. But we do identify where those areas are because we've looked at many systems where if that was incorporated, we could increase drainage from an outlet standpoint, have temporary storage within the soil profile, and have less flow downstream. At the same time, that soil profile can act as a filter and can capture some of the nutrients instead of them running off the fields.
with controlled drainage, you mentioned the outlet of your drainage pipe going to an open ditch or something, and having a structure on the outlet that essentially allows you to hold back that water into your entire field, really, and release it at a controlled rate or release it at a time when peak flows are not an issue. So really taking advantage of that water in nutrient uptake from the crop that's in the ground then too. So maybe expand on or add to how does being able to hold back that water affect downstream the water quality aspect?
Well, anytime that you can gain storage within a watershed, you can decrease your peak flows. When we look at drainage systems, when you're dealing with public drainage systems, a portion of the statute requires that you look at your 5, 10, 25-year, and 50-year rain events. We add the 2-year and the 100-year to that, and we try to utilize as much storage as we can throughout the watershed to try to at least match or reduce the peak flows downstream. Like I said previously, there's been a lot of flooding, increased intensity in rainfall events. And if we can temporarily store water, whether you do a drainage project or not, the same amount of water is going to fall within that area. If you can control it and control the timing, you can reduce flooding downstream if designed right. And there's a secondary benefit that when you do store water, whether it's in the soil profile or in a storage pond or a wetland, you get some water quality treatment by slowing it down. You get sediment to drop out. You can get nitrogen and phosphorus to drop out by doing those things.
Yeah, it's fun to listen to you explain this. And part of the water table and what we're trying to do here is connect the dots on what subsurface drainage and tiling is, and that it isn't, a 4-letter word, or tile isn't. It isn't a bad thing. And there's so many of just this first part of this podcast series of we've had episodes with Dr. Matt Helmers from Iowa State talking about denitrification of wetlands. And we had an episode with Congressman Colin Peterson, or former Congressman Colin Peterson, about wetlands and about, if wetlands are full in the fall, if we get a huge rain events all fall long, that wetland has a hard time being useful from a flooding standpoint in the spring to store more water. And that's really what you're talking about, Chuck, when you're talking about controlled drainage, is releasing some of that water, whether it's in a pond, a wetland, when the water levels are low or the flow is lower, so that has some capacity then in that pond or wetland to fill back up when it does rain a lot. So thanks for saying that, because I think it does connect the dot back to some of the topics we've talked about previously for listeners.
Yeah, and storage is kind of key in our designs. It can come in many forms. Typically, our most cost-effective form is in some sort of storage pond or basin. Just because of it takes up less land than a wetland, but we utilize as many of those different types of storage as we can when we're looking at improvements to systems.
Is there any calculations at all on that of what preferable storage is, or how are you looking at a certain amount of rainfall that you'd like to be able to store, or how does that work when you're designing those?
Well, what we try to do is we look at the 48-hour flooding or 48-hour event. So if a 10-inch rain, which in southern Minnesota is in your about 5.5 inches in 24 hours, if we can get that flooding off of the farmed areas or field areas and then store that and reduce the amount of peak flow flooding downstream, we feel that we've got a very successful project. So trying to store about 5.5 inches in a 24-hour event is kind of the target that we've been looking at. But at the same time, understanding that some of the field areas could have some temporary storage for 15 to 20 hours. So we take that into effect when we design our systems. We use what's called the drainage coefficient, or how many inches per day per acre can an area drain. The standard that we use is a 1/2 inch per day. But a lot of the systems that were put in 50 or 100 years ago have maybe a tenth of that capacity. So the new systems and new requirements for farming practices, we're trying to get up to a 1/2-inch drainage coefficient, but at the same time try to reduce that 5-inch rain event to at least the existing conditions that the old system was working. So we have to build in a decent amount of storage.
Yeah, that's impressive. I don't know what that would be, but on a typical system, the amount of gallons per water, it's staggering when you talk about 5.5 inches. But we're going to talk about drainage coefficient, I think, in another episode. So we won't go down that road because that's probably 15 minutes on itself. And I know Jason wants to talk about that in the future. So
no problem.
We will do that.
If I could just add one more thing, when you look at storage, we're trying to shoot for about 2 to 5% of the watershed. So if we're draining 1,000 acres, we'd like to store at least 10 acre feet or 10 acres 1 foot deep. We typically can do that in a smaller area, and we'll stack it up 5 or 6 feet of depth.
At Prinsco, obviously, we're seeing a shift towards larger and larger county main projects. So instead of having small individual drainage projects, we're seeing these larger mains where they're covering a larger footprint or a larger watershed. And ultimately, with that comes a lot of water. So, yeah, what kind of land would you typically use to put into a storage area? Is it, your prime farmland, or is it something that's ultimately going to be typically underwater anyway?
Well, we try to take the worst land or the most flooded land and target that area first. There's a lot that goes into designing those type of systems and areas. One way that we found is very effective is to look at 4 or 5 areas, look at multiple options, and then meet with the individual landowners and kind of go over how has their production been on that land, and is it worth increasing the production on some other land to put in a storage in this area. One thing that we've been targeting and been very successful with some of these larger watersheds, 4,000, 5,000, 6,000 acres, is finding an area in the middle of the watershed for storage. What that can do is it can downsize our outlet, because we'll utilize some of the capacity that we thought we would need by downsizing the outlet. I've got a couple examples of this on projects that are currently under construction or currently bid, where to reach that 1/2-inch drainage coefficient, we would need a 60-inch pipe. And by putting storage in the middle of the watershed, we could downsize that to a 48-inch tile, both large tile holding a lot of drainage capacity. But the storage in itself can pay for itself if we're looking at 2 miles of 60-inch pipe versus 2 miles of 48-inch pipe. The storage could pay for itself very easily and decrease the amount of flooding downstream.
Yeah, because not only does that pipe cost more per foot, but the installation of that pipe, digging that much wider of a trench, deeper of a trench, also it just adds to it. So it's kind of a double whammy on the cost difference. So just want to share that for those listeners that may wonder why it would be so much more.
Yeah, definitely. So thinking about some other edge of field practices. We've talked a little bit about wetlands. What are some other options that you see have been beneficial, or some new ideas that ISG is looking to implement?
Well, we've implemented some wood chip bioreactors, which is essentially an underground filter. If you think of like the air filter in your car, but we're digging a trench that's filled with wood chips, routing tile water through it. And then through a chemical reaction, it actually captures the nitrogen out of the tile water. We've also done a similar practice with what's called saturated buffers, which is where you take an area along a stream or a ditch, run a tile parallel to it, and then back the water up into that tile and allow nutrients to be grabbed by grasses or within the soil. And that can reduce the amount of nitrogen going downstream. One of the newer practices that we've been doing are phosphorus filters, or we call them iron sand filters, where we'll use iron filings in an underground trench, route tile water to those, and the chemical reaction with the iron grabs the phosphorus out of the drain tile, thus decreasing the amount of phosphorus that goes downstream. We've been working with some of the soil and water conservation districts and a few other groups in southern Minnesota, and we've actually implemented 2 of those iron sand filters. So that's a very new practice that we're doing. One of the projects affects one of the lakes that is having some blue-green algae issues. So by adding this phosphorus filter on the main inlet to that lake, we're decreasing the amount of phosphorus, and thus hopefully we can reduce the amount of blue-green algae that pops up in July on that lake.
Yeah, that's interesting. And can you share anything around what kind of reductions you're seeing in wood chip bioreactors and saturated buffers in regards to nitrate?
I'd say the ones that we've implemented, we're in that about 25 to 30% rate. We've had some higher numbers, but on average, we see about 25 to 30% reductions in nitrogen or phosphorus with these practices. And when you look at some of the nitrogen that's in the natural ground, that does, in some cases, get us back to the natural condition.
Yeah, speak to that a little bit, because I think that agriculture and drainage gets a really bad rap around that. We are the creator of these nitrogen and nitrate issues, and I don't think a lot of people know that there is just a lot of natural nitrate in the ground. Yeah.
I'm not the chemistry expert, but there is nitrogen in the ground. There's phosphorus that's caught in natural wetlands and other areas. And I know tiling does get sometimes a bad rap that we're carrying the water or carrying some of those nutrients out of those watershed areas. So, there is natural forming both phosphorus and nitrogen. And I mean, pre-tile, there was erosion, there was runoff because of the rain that we do see here, the amount of precipitation that we do see here. So if there's ways that we can capture some of that, control some of that, sometimes it helps offset some of the farming practices. In other cases, it can just make water quality better downstream from the natural condition.
Absolutely. ISG is heavily involved in the future of what water quality and drainage will look like. And I know you've held several workshops. Really, what is your focus with those workshops in helping reach the larger audience?
Our focus is really to try to bring private and public groups together and get people talking about the issues and coming up with solutions. We've been successful. We've had workshops in Mankato, the Wilmer area, Marshall area. We've had a few hundred people at these workshops. We try to sprinkle in tours of some practices that have been done. And my favorite part is when we get people talking. We've learned, we've been doing these workshops since 2009. We've learned that we got to schedule in just some plain old talking time into these. Because once you start talking about some of the water quality issues and the drainage issues, and you get both public and private groups together, we can come up with some good ideas. So I've given a lot of presentations at these workshops, but I've also learned a lot just from listening to people and hearing what their problems are and how the solutions work. We are planning to try to do some this year again. We're focusing on more of a virtual presentation and then doing an outside field tour. So there'll be some news coming up from us probably here within the next month on some planned field tours to show how some of these best management practices are working, and talk to the farmers that farm around them and have seen the benefits of those.
It's great to hear. We'll definitely be looking forward to more of the education and the interaction that ISG brings to that too.
And we appreciate Prinsco's partnership on some of those events. So look forward to continuing that relationship.
Well, maybe the Water Table podcast can partner in the future also.
Yeah, you could do a live broadcast from one of our workshops.
For sure. Good idea. We'll write it down.
Yep.
Water quality is something that we're only going to continue to talk more and more about. And ultimately, there's going to be new ideas. And we talked a little bit about saturated buffers and in biochip reactors and things like that. What are you seeing as far as the future of new emerging products coming into the marketplace, or different ways that we can utilize existing products to help with that water quality? One thing specifically is something that Prinsco offers in other manufacturers as well is the use of a product called flexible dual wall that really minimizes the natural the impact during installation, but also can minimize the amount of joints and things like that, where you would have less erosion of the soils then too.
Well, I'm excited about flexible dual wall because we're looking on ways to try to be more efficient. If we're gonna do multiple things within a project, both drainage and water quality, we need to figure out how to be efficient and cost effective. So by the use of practices or materials such as flexible dual wall, you can decrease the amount of time that it takes to put in some of the mains. And as we replace an aging infrastructure, decreasing cost is very important, and decreasing the amount of land that you disturb is important, which can also reduce erosion. So I'm excited to see it implemented, and we're looking at ways to be more efficient. One thing that I don't think a lot of people know about drainage, especially drainage in Minnesota, is that when you have a public drainage project, there's something called a cost-benefit ratio. You cannot spend more dollars on a public drainage system than what the benefit is. So figuring out ways to be more efficient with tiling machines versus excavators and flexible dual wall that can go in faster is very important to try to implement BMPs or best management practices into a project, because there is a cap on how much we can spend.
Yeah, that's definitely interesting. Has that been a restriction for project designs that you've faced in the past? Obviously not having enough benefit, or has that been pretty easy to come by?
It has been a restriction, especially the past couple years with lower commodity prices. I have two projects that landowners wanted to construct a storage area. One of the landowners, he had the land set aside. He's ready to make it happen, but there was not enough benefit on the drainage system. The public drainage system was near failure and needed to be replaced. So we had to move forward with the replacement without that storage area, because there wasn't enough benefit to make it work. If we can figure out how to be more efficient with tile installation, maybe we would have enough benefit to make that project work. We still set the easement aside, and if we can find some funding in the future, we're going to implement storage on that system. But the cost-benefit ratio didn't allow us to at least use dollars from the public drainage system to implement that.
The difference between plastic pipe and concrete pipe when it comes to projects like you guys are designing, they're rural, they're drainage projects out in the rural landscape, and I think I know that ISG is really speccing a lot of plastic pipe, but we do see a lot of concrete pipe throughout the landscape, especially in states like Iowa and projects like this. And what's your stance or your firm stance around why you're speccing one product versus the other?
Well, we've historically allowed both plastic pipe and concrete pipe. But on the projects that I specify, plastic pipe goes in probably about 95% of the time because of that efficiency in installation. What I tell landowners is that an HDPE or plastic pipe can be handled by two guys versus a concrete pipe that's going to take some equipment to put in. So when we're dealing with miles of footage, the cost can save up just by the efficiency of installation. And we've had good partnerships with suppliers like yourselves on making sure that these are that the plastic pipe is constructed properly. ISG actually invested in a pipe camera to both look at the 100-year-old tiles that are around and the conditions of those, and also to take a look at the installation practices for plastic pipe to help the contractors be more efficient when they construct these projects.
And, that goes to just the whole cost benefit analysis. And, I know you have a formula that you guys have to follow, but just something that we want to share on the water table is just around water quality and sustainability. We keep talking about that. And from the standpoint of plastic pipe, not so much in the history, but going forward with the new AASHTO specs that are out there, we do see the opportunity for recycled plastic pipe to become more and more prevalent in projects like this, which is a product that, is compared to concrete pipe, which has a much larger carbon footprint than when you're using recycled plastic, grinding it up and melting it back into a corrugated pipe that is going to have a cost benefit for the community in the future. So we're really excited about the connection that there can be between projects like this and flexible dual wall and recycled pipe that is the new AASHTO pipe. And just where that's going, we think there's a lot of opportunity in the future.
And I would agree. I mean, we've used recycled pipe on many of our projects, and we look at the depths and the soils and put in the product that works, that we feel works the best. And there's a lot of projects that without plastic pipe, we wouldn't have the cost benefit ratio just due to the efficiency of installation.
Where do you see, Chuck, where do you see the future of water quality shifting to, or do you think we're there now?
I think we're close. I've been seeing increased pressures from agencies and both the public that enjoys our rivers and lakes, that we need to do something when we start looking at changing drainage capacities. I see a future that there could be some sort of trading requirements where some of the storage that we do on the rural side of things could help with some of the implementation of development in urban areas. And I see an increased pressure for us to make sure that we don't increase flows downstream and that we do some sort of water quality. I work with a few attorneys that have worked in the industry for a long time, and they keep telling me that we're going to have a different set of rules in the future to deal with water quality on runoff. We already see it on the urban side of things with EPA requirements that have been actually around for a while. So I do see that coming down the pipeline at some point. Like I said earlier, we're trying to be ahead of some of those requirements, finding solutions that are cost effective and work for both the producers and can protect water quality downstream.
Yeah, I think that, what we're going to find as stakeholders in all of this, which is each and every one of us when it comes to water quality and our resources in the rural landscape of America, is that as we go, we're doing good things and we're going to see the results of them. I think we already are seeing the results, but as more and more of these projects come into fruition, we're going to see positive results around water quality and what's happening because of agriculture and because of the need for agriculture, that we're doing the right things. So, we're really appreciative that ISG is out there and in front of this and working hard to provide good water quality for our landscape. Thank you for that.
Yeah, and if I could just add one more thing to that, I've seen a change in the producer or farmer mentality, that they're very conscious about where their water goes and how it's treated. And without that, we wouldn't have been able to implement some of the projects that we do. So I've seen a change in that from a landowner perspective.
Good to hear. Good to hear. Well, one thing we like to do, we thank you for your time today, Chuck, and really good discussion and really good opportunity for our listeners to hear about what you guys are doing on the landscape with water quality. But we'd like to leave you with the opportunity. We call it the Water Table Takeaway. Anything that strikes you about our conversation that you feel like you'd like to leave the listeners with?
I'd like to leave the listeners with just the fact that in the ag community, we are doing some great things. We're consciously looking at how changes that are being done on the drainage side are affecting water quality downstream. There's a lot of good examples of win-win projects that are out on the landscape. And that if you want to see any of those, give me a shout, send me an email, let me know, and we'll show you some examples of some good things that is being done out in the ag community.
How can our listeners find you, Chuck?
ISG, my phone number is 507-387-6651. My email is chuck.brandel@isginc.com.
Good. Well, thank you so much for being with us today and for being part of what makes our rural landscape better and working hard to create a better water quality for all of us. Thank you for being with us.
Yep. Thanks, Chuck.
Yeah. Thank you so much for having me. I appreciate it.
If you enjoy what you're listening to, you can find us on your favorite podcast platform. You can find us on Twitter or Facebook, and you can also find us at watertablepodcast.com. Thanks for listening.